these topics before the end of the session. So we'll go through the definition, the Atlantic hurricane season, the conditions for the formation of storms, the stages of development, a structure of a hurricane, the naming of storms, the impacts, things you should listen for, forecast tools, and a little bit about how to track a hurricane. I hope this covers most of the questions many people have in their minds. And at the end of it, if you have any questions, feel free to share. Okay? Okay, for the definition for tropical cyclone, a tropical cyclone is a rotating, organized system of clouds and thunderstorms that originates in the tropics. Now, one may ask, where is the tropics? The tropics is this area across the globe in the shaded pink, or I'm not sure what color it reflects on your device. This general area, it includes the entire Caribbean where we are located, most of the continent of Africa, and going through north of Australia and the Indian Ocean over here. So this is where we call the tropics. It is found between the Tropic of Cancer and the Tropic of Capricorn. These are imaginary lines on the globe. This is the warmest area on the planet, and this is the area where most tropical cyclones form. Out of the ordinary, you may find something forming a little out of these boundaries, but it is not very common. Okay, a tropical cyclone also has a closed circulation. You will hear people talk about closed circulation. This is a satellite image of a hurricane, and you can see the arrows around. So a closed circulation would mean if I take the barometric pressure at different points around the storm and I connect the lines and it forms a circle. So you have the same barometric pressure all around. So that is when we say there is a closed circulation. Most times there are storms out there or systems out there, and they said it's not yet a storm because they cannot find a closed circulation. This is what they mean. They mean that you cannot find points around the system that will form a circle with the same barometric pressure. So the next one is that it has to rotate counterclockwise. In the northern hemisphere where we are located now, the storms and hurricanes spin anti-clockwise or counterclockwise. So this is an example. The winds will spin in that direction, anti-clockwise. So in the northern hemisphere, it goes anti-clockwise. In the southern hemisphere, it goes the opposite direction. It goes clockwise. So this is an image of a storm close to Brazil, which is in the southern hemisphere. And you can see with my arrows, I've pointed that it goes in a clockwise direction. Okay. And so we have tropical storms, depressions, hurricanes. They are all tropical cyclones. So tropical cyclone is the broad name, and tropical storms, tropical depressions, hurricanes, they are all tropical cyclones. So when you hear the different terms, don't get confused. Tropical cyclone is just the broad term, and then there you find hurricanes, depressions, and tropical storms come under this. Again, with names and terms in our area, we call hurricanes. In the Pacific, Eastern Pacific, they say hurricanes as well. But over to the east, in China, Japan, you'll hear them talk about typhoons. So when you hear typhoon, it's a hurricane also, but that's just how they call it in that part of the world. In Australia and over the Indian Ocean, they call them cyclones, but they are all the same. They are hurricanes. Okay, the Atlantic hurricane season. It starts from June 1st to November 30th. This is just the period of time within a year that you find most often that hurricanes and storms develop, but they can develop at any time, any month of the year. For as far as the records go, a storm has developed in every single month of the year. January, December, February. February is the least common one, but every single month of the year, a storm has developed. But these 6 months, June 1st to November 30th, is just the period of time where most of them form. So that is considered our hurricane season. Early in the season, this first diagram shows June during the first early months. You find the storms and hurricanes develop along the Gulf Coast and towards the eastern border of the United States. As we move into August, which is the middle diagram, you see the orange section that is the most likely location for development. It starts to develop closer to our island chain, the Eastern Caribbean, and off the coast of the Bahamas. That's where you have the most likely areas for development. And the final diagram is September, where we are in now. They can develop almost everywhere in the Gulf, along the eastern coast of America, and around us in the Caribbean. We have, based on historic data, August to October is when we have most of hurricanes occurring. So we call that the peak of the season between August and October. If you want to narrow that down, based on 100 storms in the past, the peak of the season is really around September 10th, which is tomorrow. So we could say that we are exactly in the peak of the season, and tomorrow is the 10th. So September really a hot month for St. Martin as well. If you go back to all the storms in the past, September is the month you will see most storms developing near or around St. Martin. The conditions for the development of tropical cyclones, some of the ingredients for any system to develop, the sea surface temperatures has to be about 26.5 to about 27 degrees Celsius. And it also is not just the surface of the sea, but also the depth. It has to be warm to a certain depth, about 150 meters. This is because most hurricanes and storms, that is where they get the energy from. They get the energy from the warmth of the ocean. There also has to be light surface winds. If the winds are very breezy, then there is not enough time for evaporation of the heat and the formation of clouds. So the winds have to be very light at the surface. There also has to be a pre-existing disturbance. A pre-existing disturbance is something like a thunderstorm or a tropical wave. Some kind of cloud formation has to be in the area to increase the possibility of development. And again, the location where this is, between 5 degrees and 30 degrees north or south of the equator. So these conditions come together will enhance the development of tropical storm. Sometimes one of them may not be present and another is present. It depends. All circumstances are not the same and a storm will still develop. But these are primarily the main conditions that has to be present for the development. The stages, the first stage is a tropical wave. In the Caribbean, on average, there are about 60 tropical waves going from the coast of Africa through the Atlantic and the Caribbean every year. On average, about 60 of them. A tropical wave will look like this in a satellite image. It is just a cluster of clouds and the winds are about 23 miles per hour. You will just get thunderstorms and windy conditions and a lot of rain in a system like this, but it is really where it starts. If the conditions that we mentioned continue to be right, the warm sea surface temperatures, the light breezes continue, it will increase and it will then move to the second stage, which is a tropical depression, where the winds will now be above 23 miles per hour, about 23 to 38 miles per hour. That is what you call a tropical depression. So the wind speed increases, the thunderstorm and the rainfall associated with it will increase. You will see in the satellite image that it looks a little better organized from the tropical waves. So these are the different stages. The conditions continue to be right, continue moving over warm sea surface temperatures and light winds. Everything is in order for development. It will then become a tropical storm, the third stage. And when it becomes a tropical storm, that's when it gets a name. So when it's a tropical depression or wave, there is no name. They only have numbers. You will hear tropical depression 13, tropical depression 9, something like that. But when it gets to a tropical storm with winds 39 to 73 miles per hour, that is when it gets a name. And we'll talk about how it gets its name later. Then if the conditions continue to be right, again, the fourth stage is that it becomes a hurricane. And a hurricane is anything from sustained winds of 74 and higher. So that's where we have a hurricane. And you can see the image is really better organized. It has a little eye in the center. So that's when it's a hurricane. When it's a hurricane, you have different categories. The categories is like a scale or a measuring stick for the hurricanes. It was designed by somebody called Saffir-Simpson, so that's why it's named the Saffir-Simpson scale. And we have the category ones where the winds are 74 to 95. We have the category 2. From category 3, 4, and 5, these are the major hurricanes. They cause catastrophic damage and devastation. Those of us who are old enough will remember the past Luis and most recently Irma in 2017. Now, a lot of people will say if it only stops at category 5, the scale goes up to 5. After Irma, we heard people saying Irma was a category 9 or category 10 or whatever. 5, anything beyond 156 miles per hour is still considered category 5, unless somebody, I don't think it's Saffir-Simpson, maybe a new person, a new scientist will develop another scale. But for now, the scale stops at 5. There is nothing greater than a 5. Okay, for the structure of a hurricane, how the hurricane is shaped. Everybody knows a hurricane has an eye. The storm doesn't have an eye. The hurricane has an eye, and the eye is the calmest part of the hurricane. It's the warmest area. There is often clear sky. If the eye is passing over you, you will know, like for Irma, we had a direct hit, so we experienced the passing of the eye. During that time, the winds have calmed down. You would see the sky. You would say that everything is fine. So this is there is usually no rain over there, over the eye. On average, the eye sometimes is roughly about 20 to 30 miles wide. The smaller the eye, the more destructive the hurricane would be. The wider the eye, the weaker it would be. Around the eye, you have what is called the eye wall. The eye wall would be different with different systems. Sometimes it's wider, other times there are even some hurricanes that have 2 eye walls. You would have 2 lines of thick thunderstorms. That is where you have the thick thunderstorms, the strong winds, and the heaviest rainfall just around the eye. So if the eye is passing exactly over you, then you would get 2 brunts of it. You would get the first part, then the eye, then you'd get the second part of it. So the eye wall is where you have the strongest stuff going on. Then you have the rain bands or the spiral bands. These can extend very far away from the center of the storm itself. Sometimes you could have the storm right over Puerto Rico, and one of the bands are all the way south on Martinique or Guadeloupe, and these have a lot of rainfall. If it depends on how fast the storm is moving or how slow the storm is moving, these rain bands can drop hundreds of millimeters of rainfall or inches of rainfall over an island. So and they spiral back towards the eye. And as we said earlier, in the northern hemisphere, in our part, it moves in the anti-clockwise direction. Now, it depends on the movement of the storm. The front quadrant, I have a line or a cross where I split the hurricane in 4 halves. The front, if it's going in this direction, the front right is the most destructive part of the hurricane. So if it's moving over you and your island is here, you may not feel the whole brunt of it. But if your island is on this side, you may feel the worst of the hurricane. So it depends on when a hurricane is coming towards you, you may hear meteorologists tell you that the front is the most destructive part. It's coming over us or it's not coming over us. So that is how we know what to expect when we look at the hurricane. Sometimes different storms have different quadrants that would be dangerous. When the hurricane hunters go and investigate the storms, they give us that information as to which side of the hurricane has the strongest winds, which has the most rainfall. And looking at its direction and where we are located, we can warn our public as to what to expect. Here we come to the naming of the storms. Long ago, before the 1950s, the storms had no names. People would name them either by saints or by the days that they were formed. You'd hear the storm of September the 4th or the storm of the January 1950 or something like that. So this was creating some confusion, because if there are 2 storms or 2 hurricanes out there, how do you warn the public? They will get mixed up and confused as to which warning is for which storm. So some order had to be placed, something had to be formalized. It first started where they were naming all storms by women's names. It wasn't until 1978 that they started including male names. It was only women before. So there has quite some history as to the naming of storms. But from 1953, the World Meteorological Organization formalized a list of 6 lists for 6 years. So these are the 6 lists that they use. They use them, they repeatedly use them. I'll show you how in a while. So this is 2017, and you can see in red we have 2020, where we are now, and 21 and 22. Now, how they use them is that the same list that was used in 2017 will be used again 2023, so in 6 years. The list that was used in 2018 will be used in 2024. The list of 2019 will be used 2025, and the list we are using now, 2020, will be used again 2026. Now, if the names are only changed if something really devastating happens. For example, in 2017, we had Harvey and Irma. Everybody remembered Irma, how destructive it was. Only if the storms or the hurricane, has done a certain amount of devastation or caused a certain amount of deaths, their names have to be replaced, because you don't want somebody saying the 5 people died from Lewis in 1995, and then you use the same Lewis again another year, and then you have to refer to Lewis, you will cause some confusion. So Lewis was replaced years ago. So back to 2017, Harvey, remember Harvey caused destruction in Texas in August of 2017. Think like 68 lives were lost and over $100 billion damage. Irma, we all know about Irma. Irma had 7 landfalls with 5 of them at category 5. We had also Maria and Nate. Maria caused destruction in Dominica. 31 lives were lost and 34 people are still missing. Nate caused some destruction in Central America, I think like 44 deaths. So these names have been removed. These 4 names were removed in 2017 list. Now, who removes the names? Every year after the hurricane season, the directors of all meteorological services come together to analyze what happened for the past hurricane season and how they could put things in place to better the way things were handled. So they meet after every hurricane season, and they are the ones who replace the names. So depending on the reports from the various countries as to what destructions occurred, if it gets to the category where it has to be removed, the names are removed. If it's a male name, it has to be replaced by a male name. If it's a female name, it has to be replaced by a female name with the same letters. So in 2018, after they analyzed the list for 2017, the names were changed. You can see that Harvey changed to Harold. So in 2023, you will not see Harvey, you will see Harold. And Idala replaced Irma. Margot replaced Maria, and Nigel replaced Nate. So that is how they replaced the names. Now for 2019, no names were removed because in 2020 we had COVID and there was no meeting to analyze the 2019 season. So they have agreed that in 2021, they will retire names for both 2019 and 2020. So you will not see the changes until 2021. Now, what happens sometimes is that the 21 names that are given for every year, if the hurricane season is very busy and you run out of names from that list, as you can see this year, we are busy running out of names. We only have 4 names left: Sally, Teddy, Vicky, and Wilfred, and we are only in the second week of September. So it may be very likely that we may run out of names. When we run out of names, what happens? We turn to the Greek alphabet, and you have this list to follow. So this is the Greek alphabet. You go through alpha, beta, delta, and so on. In the last time we did that was in 2005. We got all the way down to zeta, to the Z1. So 2005 was very busy, and this one happened all the way in December of that year, outside the hurricane season, and it extended into January. So 2005 was a very busy year. So once we run out of names, we turn to the Greek alphabet. So we hope this year we won't get too far into the Greek alphabet if we have to. So impacts, we are all familiar with the impacts, 3 main impacts from hurricanes and storms. Storm surge, where you have the abnormal rising of the ocean, and this can happen way ahead of the center of the storm itself. Do you see the seas start acting up way before the hurricane or the storm gets to your area? And waves can go as high as 20 feet, depending on where you are. We have the destruction of the winds. This photo was taken near the airport, Juliana, on the very morning after Irma. You can see destruction that the winds can cause. We all familiar with that, where roofs can be damaged and loose things become missiles, down-powered lines, and disruption to our life. The third impact is heavy rainfall, where we are faced with flooding, and we are very familiar with that on St. Martin when it comes to flooding. And it doesn't even have to be a storm or a hurricane. It could be a heavy rainfall event from any light system, a tropical wave, and then rainfall can be very destructive as well. Things to listen for, we have hurricane watch or storm watch. This is when the hurricane or storm conditions are possible, not really sure, but it's just possible. That's when you have a watch, and it comes like 48 hours. Not, we don't stick to 48 hours because sometimes the time doesn't matter there. The system develops so close to your island that you do not have 48 hours. So this is just a measuring stick, but it doesn't have to be 48 hours. Just to know that a watch is when the conditions are just possible in your area. Warning is when it is expected. So we are more certain when we put a warning that we are going to get affected. Again, the time doesn't matter here, depending on where the system forms. Other things to consider is adverse weather conditions for hurricanes and storms can occur well in advance of the eye. It may be a few hundred miles away from your island, and then you start getting effects because the storm or the hurricane is very wide, and you have the rain bands that we spoke about reaching your island way before the eye. When you are plotting a hurricane or storm, it is just the center. When you hear the coordinates, it's just the center that you are talking about. You have to remember that the storm or the hurricane is much wider than that. Another thing to remember is tropical storms and hurricane force winds. They extend out from the center to a certain distance. And in the advisories, you'll always hear storm force winds or hurricane force winds extend from the center to about 150 miles. You have to think of that and your distance from the center. These are some of the tools that we use. This is a radar image. It tells us the rainfall associated with the system. The brighter the colors, the heavier the rainfall is. As I was saying earlier, sometimes the rain bands can be very far away from the storm its center. You can see the center of the hurricane here, and then the rain bands are affecting these islands all the way down south. So on a radar image, you can see where the clusters of rainfall are. This is called a visible satellite image. You can see the clouds, and it can help you locate the center of the system as well. You can see where thunderstorm clouds are located. So these are some of the tools that we use. This is another satellite image. It is called the infrared satellite image. The bright colors tells us the temperature of the clouds. So the colder the clouds are, the heavier the rainfall associated with it. This is another thing that you hear talking about the hurricane hunter. During hurricane time, they use the Air Force. The US coordinates the hurricane hunter. They send the aircrafts, they have the trained military and scientists to go aboard these aircrafts and to do the measurements for us. This is how inside of a hurricane hunter is. It is a very rugged ride to go through a hurricane. You can see everywhere is padded. You have to be strapped down. This little equipment you see the gentleman holding, this is what gets the information for us. It is called a drop sound. It is dropped at different points around the storm when the aircraft is flying, and it feeds information back to the computer to say how strong the winds are, the temperature out there, the pressure, and all the other information that we get. This is a image of a aircraft flying over the top of a hurricane. And this is what the instrument looks. So they drop hundreds of these things over different points, and then the information is sent back. This is what we get, the advisories that we get. It will give you what distance the eye is from different islands. It will tell you the maximum sustained winds, the present movement of the system, and what direction it is going and how fast it is moving, and the pressure. The pressure tells us how strong the system is. So the lower the pressure, the stronger it is. The higher the pressure, the weaker it is. Okay, I'm just going through a quick exercise, how to track a hurricane, just to give you an idea. This is St. Martin. St. Martin is located at 18 degrees north, 63.1 west. My point is big just for demonstration, but it would be a very, very small point if you have to use a pencil. Here is an advisory. That is what we would get from the Hurricane Center. What you have to take note of is the number of it. So this was for 2014 Tropical Storm Gonzalo. This was the first advisory that went out, and it gives us the location, 16.4 north, 58.4 west. So that is what we would look for on our map. 16, just a little above 16, and then the longitude would be the lines that goes from north to south on our page, and the first one would be from east to west on our page. So this is the location here. My point again is big, just for demonstration. So this would be the location of Gonzalo at that time, 1:30 p.m. on the 12th of October. The wind speeds were 40 miles an hour, and it was moving west. That means it was moving straight in this direction towards Guadeloupe at that time. We note the pressure. Pressure was 1009 millibars, and it was moving at 10 miles per hour. The entire system was moving at 10 miles an hour. That was kind of slow. So these are the points that we have: how fast it is moving, where it is going, the strength of the winds, and the pressure. Now this is another one, but this is number 6, so that means we had about 5 in between. So I just skipped a couple just for the demonstration. So this was 5 p.m. on the 13th, and the location of the system is now 17.9 north, which is the east to west line, 17.9, so it's almost on 18, and 62.9 west, 62.9, so almost 63, which would bring us about here. So it's now very close to St. Martin, as you can see. And from the last report, we had that the winds were 40 miles an hour. You can now see it is 75. So it is now a hurricane, not a storm anymore. It is now moving northwest. So when the first one we got, it was moving west. So apparently between the first advisory and the sixth advisory, it started moving northwest and headed in our direction. So if you are following and trying to track a storm, you need all the bulletins, or else you will miss a point. And now the pressure is 984 millibars. That means it's getting stronger, because on the first one we saw it was 1009 millibars. So the lower the pressure, the stronger it gets. It is now also moving at 12 miles an hour, so it has picked up some speed, because earlier on we had 10 miles an hour. So these are the different things that you look out for in advisories: the maximum sustained winds, the movement, meaning the direction, the speed, how fast it's going, and the minimum central pressure. Just a fast thing for the 2020 season. You may have heard about the predictions earlier in the seasons, where scientists and majors people doing their PhD look at past data and they try to come up with a prediction for each season. I always tell people the prediction doesn't matter. We know we live in the hurricane belt. We know we have 6 months of the year where we have hurricanes and storms, so we just be prepared. It could be, they could tell you that this year is going to be an active season and you don't get hit. And the year that they tell you that it's not going to be an active season, that's the time you may get hit. So the important thing is whether you get hit or not really the prediction. So you always have to be prepared. So the last predictions, well, before the predictions, on average, based on data from 1981 to 2010, on average season has about 12 named storms, 6 hurricanes, and 3 major hurricanes. That is category 3 and up. NOAA, which is the National Hurricane Center in Miami, their last predictions has increased their numbers to 19 to 25 named storms. That's what they expect in this season. So you see they have 25, so this is way beyond our 21 on our list. So for sure, if it has to go by this, we are surely going into the Greek alphabet this year. The Colorado State University has theirs at 21. For hurricanes, NOAA says 7 to 11 and 3 to 6 major. The Colorado State University says 12 hurricanes and 5 major. So far, we have had 17 named storms. So we are already way above the average season. We have had 5 hurricanes and one of them major, that was Laura, that made landfall in Louisiana. Um, the reason why we have such an active season uh, are listed here. One is because so far the sea surface temperatures are very warm over the Atlantic and the general area where storms form. We also have let me show you. This was taken yesterday. This is the average temperatures over the Eastern Caribbean and the Atlantic. You can see the reds where we have the warmest above normal areas. In our area is above normal, is about 0.8 to 1.2, but it's above normal anyway. Here are the actual temperatures taken yesterday. We saw that earlier that the temperatures needed for hurricane and storm formation is about 26.5 to 27. And you can see the temperatures all around here are above that. And these were the temperatures for yesterday. So you can see our area is very warm. The second one is because there is a possibility of La Nina occurring. La Nina is a whole topic by itself. I'll just try to breeze through it. La Nina is enhances storm development in the Atlantic. You have the cooling of the sea surface temperature over in the Pacific, and the opposite happens for us. We have rainy conditions. You hear about La Nina and El Nino. El Nino is good for us for the hurricane season. We have less hurricanes happening during the El Nino period, but La Nina, we have a lot of rainfall and increased possibility for storms. So it enhances storm development. So what the scientists have come up with is the blue bars are for the possibility of La Nina. You hear SON, September, October, November, December. This is like the peak of our hurricane season, and the possibility for La Nina is the highest. So that is one of the reasons why all the forecasts have gone for above normal conditions for this hurricane season. Additional things are weak wind shear. Wind shear is where the winds are very strong in the upper levels and they can break apart storms developing. If these winds are very weak right now, then the storms are going to continue growing. So this is another reason. And the last one is the active monsoon season in the West Africa. You can see all the rainfall and the little systems moving off the African coast, very busy these days. So this is as a result of the active monsoon season in West Africa. What this is a picture of the tropics today. I took that just about 5 o'clock. We have our two storms, Paulette and Rene. They are both forecast to stay over water, which is a good thing. And we have this little one out here near the east coast of the US. It has a 30% chance for development. And we have this over here over West Africa, waiting to move out by tomorrow. It should be out. And it is forecast to become a depression over the weekend. Because it is not yet over sea and it has not formed into anything as yet, the models have not been treating it well. But for now, we need to keep an eye on this one. It should be the next one, which is Sally. So hopefully, as soon as it gets out, we'll be able to get a better hang as to its decision as to where it wants to go. But this is something that we should keep an eye on. And are you prepared? These are some of the things that we have been hearing, but sometimes people do not really take note until they hear something knocking at your door, and tomorrow you see people busy running about. But these things that we should have from the beginning of the hurricane season. The extra water and non-perishable items and the flashlights and the batteries. Check up on ourselves and don't let the last minute catch up with you. You know how it goes in St. Martin when you start to rush about, then you start to panic and you don't know where to go. All your plans should be in place. If you don't expect to remain at your house during a hurricane or a storm, you should have already known where you will go for refuge. Whether it's at a shelter, you should know which shelter. If it's at a friend's home, you should know which friend, and everybody in your family should know where we have to go. If we are staying home, which is the most secure room that we are going to use. If there are branches above our house, we should have cut them already. Don't wait for the last minute to do these things. So there are things that we could do before that will help us not to panic at the end. So that's all I think for now. If you have any questions, I hope everybody understood.
Thank you so much, Sheryl. Every time I wrote a question, you already answered it before I can ask. It was very detailed and very, very informative. We keep talking about hurricanes, like, oh, hurricanes. We don't really understand what a hurricane is. And this was very, very informative. Okay, I see Cookie has his
Somebody
hand
has a
up.
question.
Yeah. Cookie?
Thank you, President. Shirley, I should really applaud the way you made this presentation. I believe in so many presentations that I have looked at, I would say you stand number one now. The way you made presentation, I'm telling you honestly, the detailed work and all, whatever you did, never felt even one point that it is boring or wanted to swing away, but it was a very well presented. I have a couple of questions. First thing, how much of the data of the American meteorologists you use to shoot out your data, or your data is based from somewhere else?
You or
Sheryl, we
did you
can't.
hear me?
No, we didn't hear you.
Shirley, I think we lost your voice here.
these people to a place of safety following due process, and also respecting that they have rights to the dignity, to the services, the healthcare that
I think she's logging back.
Huh? Man, she did a fantastic. I'm surprised you didn't come and listen more.
Bernadette, your mic is on.
I think she lost
Sorry.
connection. I think she lost
I'm so
internet connection.
amazed
I'm
at
really
this.
hoping she can come back.
Yes. Oh my goodness. What a presentation. I was telling
Oh, yeah.
Carter, why aren't you listening? Because he's so fanatic about these things. I was like, why aren't you here listening to this?
Okay, she's back.
Okay.
Give her a second to join in.
Tony, please put off your mic.
Good night, everybody. I like the
Good night.
program. She explained a very good, but I don't understand this. I appreciate to the Rotary Club. They put it on a Facebook. Only I see 13, 14 people. They don't want to hear the knowledge about the hurricane.
Sheryl, where is she?
She's here. She doesn't have a camera
I am
on.
using a desktop right now at the office, so it doesn't have a camera on.
Okay, so you're not on the camera. Okay,
Right.
Sheryl, my question was the data which is circulated in St.Martin, particularly of the weather reports, which you send out and which is out from the US. Is it a copy paste from them, or is it different to what the US data is, or the synopsis of the incoming hurricane or incoming weather?
The way weather works, there is no political boundaries, so we work as a team. So all the information for our area, which is region 4, which is North America, the Caribbean, and Central America, we all get our information from the National Hurricane Center. But what is done is that you take this information and then you tailor it for your area. So they would give you a distance, then you would have to tailor that distance and say the distance from St. Martin. If they say that it's expected to give you such and such waves, then you know if it is coming, depending on the direction it is coming towards St. Martin, you as the meteorologist would know what side of St. Martin it's coming to, then you would tailor it for your area. But the information coming from the National Hurricane Center is for the entire region 4, which is the Caribbean, North America, and Central America.
Okay, got it. 2 more questions.
No problem.
The second one is, you were just on the last slide where you showed the 2 tropical depression which are just formed, and the one on the east coast of the US. The last one you said, which is going to be coming by the weekend.
Okay, correction.
It is not developed into the sea. You're still predicting from the land base?
Correction. Okay, the 2 that are out there are 2 storms, not depressions, okay?
Yeah, 2
No,
storms, sorry.
okay.
Yeah.
So there are 2 storms. These, based on the models, they are expected to remain at sea and to go to the north of us. The one that is on the mainland of West Africa, it is projected to move to sea tomorrow, Thursday. Okay.
Oh, so these conditions can develop on the land, not just in the sea. It
is
can
not
start
yet. It
on
is
the
not
land.
yet developed. It is just a tropical wave over the land of Africa, and
Okay.
it continues to move westwards. When they are expecting, based on the conditions present there, it is expected to move over water tomorrow and to be a depression by the weekend. So
Okay.
that is why I said we are supposed to monitor it, to keep looking at it to see what direction it is heading to. But it is very far away.
Yeah. Got it. The
Yeah.
third
So
question
it
that
is
I have
not
for you
coming.
was,
It is
I
not
think,
coming this weekend. It is expected to become a depression by the weekend.
yeah, that's what I totally understood. My question
Okay.
only was that we always think that the hurricanes or the storms which start or develop, they form in the sea. I
Oh.
never had in my mind that it can originate on a land also.
It can, remember, when it makes landfall, it can move over land as well, but over land it has less ingredients present to develop. Over, once it moves over land, it kinds of disintegrates because it lost its feeding band from the ocean.
Yeah, that part
So it's
I
weaker over
understand.
land. Yeah. What's your next question?
Good night, everybody. Sheryl, you good night to you
Yes.
personally. You explain a very, very good. Nobody
I think this question was,
good knowledge you gave us today. God bless you.
Thank you very
yes,
much.
God
My
bless.
pleasure.
Good night. Good night.
Okay, good night.
God bless. God bless you, Tony. Okay, Sheryl, the last explain how you measure rainfall in millimeter or inches.
Repeat your question. You were kind of breaking up.
I said in layman's term,
Mm-hmm.
can you explain how a bird measure rainfall either in millimeters or inches? Like how can I measure it? Or does it have
Oh.
to be through you people only that I can understand what millimeter or inches the rainfall is?
Okay, the millimeters, we have the measuring cylinder
Uh-huh.
that is calibrated especially for measuring rainfall. So we use that to measure the rainfall, and we convert the millimeters to inches. So you need to have.
Yeah, that, but I'm not worried. Either in millimeters or in inches. I'm saying, how will I measure sitting at home? Is
Okay,
there,
at
if I
home.
have the what do you call, a glass with the millimeter written on it, can I just put it out and measure the rainfall?
You can, but your glass has to be located in a particular area. You don't just put a glass under your guttering or somewhere. It has to be somewhere that is not shaded. It hasn't got to be under a tree or close to any building. You are supposed to have it in an open area that the rainfall that is falling into that jar is not altered by anything at all. So it has to be the direct rainfall falling. And you could use a ruler. If it's a clear glass, you could use a ruler to measure the centimeters,
Direct
millimeters.
in. Good.
Okay, you're
Thank you.
welcome.
Any other?
Sounds like Cookie wants to change careers.
It looks so.
Well, Sheryl, I want to know, where have you been hiding? We have all been, I would say, mesmerized by your presentation. And I also want to know, do you visit schools, or maybe are schools aware of you? Because you don't see young women, especially in our area, going towards that kind of study. And especially in our area, I think it's such a wonderful opportunity. Sometimes, you have to be out there and give choices to young students, but especially young women. So I want to know, where have you been hiding all this time?
I have not been hiding. I am right here. I have been to many schools to do
Oh, that's good. That's
presentations,
good.
the
That's good.
primary schools a lot, and a few
Okay,
of the
cool.
secondary schools. And
Okay,
we have, since I have been here, we have recruited about 3 young women from St. Martin.
wonderful.
So we have 3 young women on our staff.
I am from the Friends side, and I know we probably wouldn't get the honor of having you visit our schools, but we're missing a lot.
Oh, if I am invited, I will surely come. I go to all the schools that call me.
Okay, I'm going to find out how we can grab you for something.
Okay, no problem.
As you can see, everyone loved your presentation.
Oh my goodness. Oh my goodness. Wow.
Any other questions?
Can you explain,
President,
Sheryl,
you
about
have the recording, right?
Yeah, it's recording.
Please share it, and if we can get the presentation, what she had used, and if she would like to share it with us, highly obliged to have that.
Okay, I can send it to Dolly.
Thank you
Yes,
so
please.
much.
Thank you so much.
Somebody had a question, Claudia?
Yes. Can you explain, Sheryl, about the pressure? You said, is it the higher the number or the lower the number that the hurricane has a lot of pressure?
The lower the pressure, the stronger the hurricane.
Oh, okay.
So if you heard in a first advisory that it was like 1,000 millibars, and then the next one you hear that it's 900 millibars, that means the hurricane is strengthening.
Okay, so if it's 1,000,
and then the next one you heard that it's 900 or lower than 1,000, that means it's strengthening. If the pressure is increasing, it's getting weaker.
Okay. Thank you.
Okay.
Any other questions?
No more questions.
Okay. Sheryl, on behalf of our club, thank you so much for this presentation. I am going to try to put this presentation on, I'm going to try to put this video on our Facebook page. Everyone is free to share it.
Okay, nope.
Again, thank you so much. And
okay, thank you for having me. It was my pleasure.
And at this point, I would like to end the meeting. Thank you everyone for coming, and thank you for joining us with this presentation. Have a good night.
Okay, good night, everyone.
Thank you.
Good night, and thanks.